Thank you, and welcome. For those who aren't familiar with us, Churchill Club is a nonprofit organization dedicated to encouraging innovation, economic growth, and societal benefit. And the topic of tonight's conversation has the potential to contribute to all three of these things. It is called Training and Applying AI, Strategies and Trends, and What Comes Next. The potential of AI to spur transformative change will largely be made possible by training, validating, augmenting machine learning with people. And AI models need accurate, precise, structured training data to see, hear, and talk and think like humans. We have with us a diverse group of accomplished experts to contribute their newest perspectives on this topic. It's a pivotal strategic area. So what does it take to train AI to be really good, and how is this going to evolve in their estimation over the next, say, 5 years? We have Matt Bencke from Mighty AI, Raz Ho from TiVo, Amir Khosrowshahi from Intel, and Jim McHugh from NVIDIA, and here to lead them in conversation, we have Robin Murdoch, Global Industry Managing Director, Software and Platforms from Accenture. So we'll bring our speakers up in a moment, but first we want to tell you something that's quite important to us on your behalf, which is that we ask our speakers always very respectfully not to pitch or promote, but rather to think of themselves as having an opportunity to advance collective understanding and hopefully shed light on some new opportunities. And maybe if you all walk out of here with some insights that are new and feel charged up, then that will be a measure of success of this program. First, before we bring up our speakers, I want to thank our Accenture partners, Julie Rosendahl, Robin Murdoch, Kevin Collins, and Lisa Davis, without whose intellectual and financial leadership this program would not have been possible. So thank you very much, Accenture. The hashtag for tonight's program is Churchill Club. You'll find other Twitter information in your printed programs. And now let's call up our speakers and moderator. Welcome.
Okay. There we go.
Thanks very much, Karen, and the Churchill Club for organising the event this evening. So, as Karen said, our discussion is going to be on the broad topic of artificial intelligence, and we're going to focus in on this topic around human training data, which really feeds the development and continual improvement of AI models. Just context setting, because AI covers so many different areas. It involves multiple technologies that allow machines to sense, comprehend, act, and learn. And this includes technologies spanning machine learning, computer vision, and deep learning, and in the future, many more. And we'll cover, no doubt, a number of those topics on the panel tonight. It's underpinned by unlimited access to computing power, both in the cloud and then increasingly at the edge, in your smartphone or your car. And it's also underpinned by the growth of masses and masses of data, and we'll hear about that on the panel tonight. It's also foundational to the next generation of many of our digital experiences. You may have heard this week Apple's improving the voice of Siri by using AI. Tesla's using AI to improve the ability to move towards self-driving cars. So it's a time of incredible change. We've got a fantastic panel in Amir, Jim, Matt, and Roz to help us understand the space. So I'd like to kick off the discussion with each of you introducing yourselves. Roz, would you like to start, please?
Sure. So I've been in what is used to be called the software industry. I don't really know what to call it anymore. For probably about 30 years, I actually blame my interest in computer science, and it's kind of an interesting wrap to this, on my reading Isaac Asimov's Foundation trilogy. I don't know if any of you are old enough to remember that, but it was actually a lot about artificial intelligence. And so, many, many years later, here I am sitting on the panel although I'm not an AI expert, I am looking forward to using this technology to apply to the TV and media industry. But, just really quick, 20 seconds. I spent 22 years at Microsoft working on various products, probably longest on PowerPoint. I started there in 1991 when nobody knew what PowerPoint was. I was on the original team. Spent 10 years on that. Don't hate me. Don't hate me. I just created a pen, okay? So, and then, went on. I ran the Macintosh business unit for about 4 years and had the privilege of actually working with Steve Jobs while I was running that business at Microsoft. I spent 3 heartbreaking years at Microsoft working on their phone software. You all know how that story went. And then a year on the Xbox. And then 3 years, about the last 3 or 4 years working at Ericsson, Microsoft Ericsson, and now TiVo in the TV and media industry. I started as a software engineer, so wrote a bunch of code. Hopefully none of us exist anymore because I've been a general manager probably for the last 15 years or so, running large engineering teams and trying to run a business and take care of the P&L and all that other good stuff. So,
fantastic. Matt?
Sure. Okay. Hi, everyone. And thanks a lot, Rob and Karen and everyone for hosting us. It's really fun to be here. So I hope tonight's fun for you. So briefly, I'm Matt Bencke, and as you know, the founder and CEO of Mighty AI. I'm from Pittsburgh, and you can blame me if you're a Golden State Warriors fan because, I wanted to make sure this panel wasn't the night of the Penguins game tomorrow. I come from Pittsburgh, which has come a long way in many ways. Is an interesting story in and of itself, but now live in Seattle and have a little bit of an eclectic background, I suppose. Studied physics and astronomy here in the U.S. and then in Russia, and then worked in aerospace programs in aviation for the Boeing company for 10 years, and then went to work for Microsoft, where Roz and I had the pleasure of working together. I worked in Windows and in mobile, shared some of that heartbreak and good adventure, and then on Xbox. And then went to run the product and software teams at Getty Images before heading out on my own to found Mighty AI. Somewhere along the way, I got lost in academia, got a PhD in political science here at Cal Berkeley, and studied Russian and East European studies at Stanford in between. So anyway, it's great to be here.
You should think about a career in politics again.
Yeah, that'd be great. Now that I know how to use Twitter, I could probably do that.
Jim?
Well, who said I had to follow him? But anyway, I showed up, thought I had pretty nice shoes today, but I realized I had the second nicest shoes on the panel. Hey.
Third?
I don't know. Did you see Roz?
So,
Jimmy Choos.
Sounds like most people up here, started my career in Silicon Valley working for Apple. I've worked at many different startups, Sun Microsystems. I see some old alumni from Sun Microsystems here. I was actually at the Churchill panel where both Scott and Larry were at it and announcing that acquisition. That was quite fun. From there, I went on to a couple more startups, was at Cisco Systems, oversaw the compute line there, a lot of the solutions. But I have to tell you, I've never had more fun in the last 1.5 to 2 years when I've been working in AI. So I look forward to the panel tonight.
Great. Amir?
So I came to the U.S. as a political refugee from Iran. And from there I went on into high-energy physics in my first effort at being in science. And as many of you know, if you're a physicist, the only job you can get is on Wall Street. So from physics, so I studied string theory, and then I found myself at Goldman Sachs, and then I found myself managing billions of dollars of money, and you can see why the financial system is screwed up. So this was in the 90s. I was a derivatives trader, and from there I went into ski mountaineering. So I left my career to travel around and climb and ski. That's as complicated as I can present it. From there, I went to get a PhD in neuroscience at Berkeley, and from there, I found a bunch of other neuroscientists to obviously start a chip company. That makes a lot of sense. And then that company's name is Nirvana, and it was acquired by Intel. And now I'm at Intel, and I'm the CTO of the AI arm at Intel.
Wow. So we're talking about artificial intelligence, but it seems we have quite a lot of raw intelligence on the panel tonight. I don't know whether we need it. So with such a diverse set of panelists, I thought it'd be interesting to get started with talking about, in your current role and in your current company, how AI plays into what you're doing. What are you doing in the AI space at your company? And maybe some examples of sort of interesting applications. And maybe we can start with Amir.
So today, without mentioning my company so much, businesses are starting to adopt AI at a very rapid rate. So it's making quite a material change. There is the companies that have a lot of mind share. There's Google, Facebook, Microsoft, Amazon, and so forth. And then there is a huge enterprise space that's not being addressed. And then there's lots of developers, a really smart guy in Bulgaria who has a startup, and so forth and so on. So there's a really large landscape of users of AI today, and my company's job is to service all of them. So it's very interesting and challenging, and my role as the CTO of this group is to devise an AI strategy for these businesses. Because AI is quite hard for a whole host of reasons. You have to buy stuff, hardware, software, and you have to have data scientists. And the problems that people want to address in enterprise are not potentially in academic papers. They're novel. They require lots of banging your head against the wall alongside your customer. And this is a new thing for this iconic chip manufacturer to be in this space. But because of the difficulties of the space and the rate of adoption, it's really necessary. And it's a novel thing for Intel to have an AI vertical unit. And it's kind of the sign of the times that you actually need this to help people adopt technology at the rate they need to be successful.
Jim.
Great. So Jim McHugh. I work at NVIDIA. Most people probably know us for meeting the needs of the most demanding users in the world. And by that, I do mean gamers. And we've gone on from then since to do many other things. And literally everything we do pretty much now is focused on deep learning and AI. And what I think is fascinating about it is when you say you work in AI, it means today you work in the automobile industry. It means you work in healthcare. It means you work with a lot of researchers. You get exposed to robots, manufacturing. There's so many things that are going on. You get to work with great companies like SAP, as they made a big, bold move into AI recently as well. So just a really exciting thing to do.
Matt.
Sure. So thanks. At Mighty AI, we provide what we call training data as a service. So we're about a 45-person startup, as I mentioned, up in Seattle. And what we do is we provide the clean, structured data that our customers need to train their models and then validate them out in the world. And so, for example, we work with companies as diverse as GoPro and Pinterest and Snap or IBM, Microsoft, and quite a few automotive companies to help their computer vision and their natural language models understand what people think so that their models are trained and functioning. And then once they're being applied, we have ways for them to test and verify and validate and improve them. So long short of how we do that is we have our own machine learning that has predictive models of human knowledge. And we have 200,000 plus people who use our app and our website every day to complete these tiny little micro tasks to help us understand what they think, feel, see, hear, and so on. And our long-term goal as a company is to create mathematical models of human knowledge so that we can tap potential brain power easily and on demand and make it available for the optimization of man and machine working together. So it's early days, but it's pretty exciting.
Rose.
Yeah, so, I'm going to actually switch gears a little bit. Obviously in the TV and media industry, there's a lot going on around discovery of content, search, and recommendations, and all of those things that you can apply AI to. The problem that sort of grabbed me, I've actually only been at TiVo for about this is week 9, okay? But I'm going to talk about something that we're doing right now that I think has sort of some societal implications, which is, I have a big team of people that literally create metadata for entertainment content. So they're sitting there, they're typing, they're curating, they're, writing editorials and all of that. And actually, with knowledge machine learning and with AI, we're going to automate a lot of that. Like, this is going to happen in probably every vertical industry you can think of, right? So it's exciting in a lot of ways because I'm actually watching, like in real time, the application of the machine learning and the AI to transform a business. But it also has a lot of impact on people on the team because all of these people that are typing in content, we will no longer need them. But, we're not going to get to 100%. So what really is happening is these people are their jobs are going to change. And they're going to have to learn to different skills and do different things in order to stay current in the time. And I mentioned this problem instead of all the other ones, which I'm sure we'll also talk about, because I think we should all think about this. Just what does this actually mean for our society?
Well, that's great. Let's build on that topic. So maybe let's get level set on the role of the human in training and instantiating AI, both in terms of kind of active AI training that you're doing, Matt, but also in that passive data collection roles that you're talking about. So Matt, maybe you can talk us through how humans are being used right now in training AI, validating it, and augmenting it.
Sure. Jim hit on it. People are applying machine learning in pretty much every vertical you can name, and maybe not equally, and maybe not within the industry equally. But at Mighty AI, in some ways, I feel like we're laboring in the boiler room with dozens of companies in this space to help them, again, train their models. So I think of it as in the following way. There's 4 components to any AI model. There's the infrastructure, which the gentleman to my left understand very well. There's the frameworks in which you're building your models and the actual algorithms themselves. There's the human training and validation data, and then there's the application of it. And, a model is only as useful as the humans who've trained it. And so the trick for a lot of our customers is either gathering data and labeling it cleanly and precisely, so you know exactly what most people will see or hear when they see an image or hear some speech, and then using people to validate it, right? So just because the computer thought that, and we all experience this all the time. If you've used, whether it's Google's, Amazon's, Apple's, and or Microsoft speech assistants, the success rates hover between the high 80s and the low 90%, and it's incredibly frustrating. And that's not because Apple, Microsoft, and those other companies don't have tremendous people and compute power and models. It's often because of the difficulty of gathering precise training data and structuring it in a way that they can train and then validate their models. So in our short experience as a 3-year-old company, what we found is some of the best teams in the world are, come into AI with, broadly speaking, a blind spot to the difficulty of getting us pesky, squishy humans, to express our opinions in a way that computers can understand.
Matt, could I ask you to maybe give an example of what training AI means, what active training AI means? I think we all talk about it, throw it out. But, what are you getting your big crowd to actually do?
Sure. An example that's top of my mind today, because we just opened an office in Detroit, is the automotive space. So, obviously there's this incredibly exciting, hyper-competitive race to create AI-assisted vehicles. And, what we do for quite a few companies in that space is help them process terabytes or even petabytes of data to label them. And label just means, when you have a picture of somebody driving down a road, where's the road markings, where's the pedestrians? If you identify a pedestrian, what's their intent? Are they going to cross the street or are they holding still? If they're about to cross the street, which direction do we think they're going? Computers need trained from the beginning to the end. And so an example might be, an emergency braking, an intelligent emergency braking system deploys. Why did it deploy? Well, it saw something crossing the road. It presumed it was a pedestrian. That generates an event. It's very easy for you and I to look at one frame of that video and say that was a pedestrian or that was a plastic bag. Our automotive customers have a big challenge to do that at a massive scale with high reliability in different lighting conditions, different weather conditions, different geographies, and so on. And that's a good example of what we do every day is get people to help them identify the pedestrian, not the shopping bag, and then validate what it actually was.
Yeah. Amir, it seems like every week I'm reading some article in the paper about some amazing technology breakthrough that means that humans no longer need to be involved in the training of AI. Where are we at in that? What are the techniques that we're seeing that are taking the human out of the training, and will we see a point where we don't need the human involved?
So good question. So there's when you're trying to build a machine learning model, there's of course, as Matt said, curating a data set. If you have a good data set, you have high quality input, then you get high quality output. This I know very well because I was in the field of neuroscience, and neuroscience data is notoriously difficult to work with. It's almost maximally uninformative. And no analysis yields anything. So working in neuroscience, I understand the value of well-curated, annotated data. There are other settings where you can use other strategies, and if you look at machine learning, it's one way to split things up is supervised and unsupervised, and then reinforcement learning. So supervised means that you have samples and labels. Unsupervised, you just have raw data. So this was actually the topic of my thesis, is if you stick a big needle into the brain and you record, and you don't really know how the system works, you get data, how are you going to label it? So unsupervised learning, you want to learn the statistics of the data. There's a probability distribution that describes the data. I don't want to get into too much statistics. And the goal of this strategy is you want to build a model of the data that's rich enough that if you sample from it, if you hallucinate from this model, it generates data that looks like the real data. Then you have this thing called analysis by synthesis, and it's a success, because then the next step after this is you can do things like calculate means and use it for a whole set of other things, including training when you have a very limited set of samples. And then that's one strategy, is unsupervised learning. Another strategy is to build a simulator for your system. So in the case of the Large Hadron Collider, for example, it's the biggest producer of data in the world today. It produces on the order of a petabyte per second. It's triaged down to a petabyte per day. So the Large Hadron Collider has these detectors. 25 nanoseconds, you have things colliding and producing high-dimensional data. So in that case, the human mind just cannot anymore understand the actual output of a single collision, much less a petabyte of data. It used to be in the 30s and 40s, you had bubble chambers, and you had really smart physicists who looked at little circular patterns and could identify evidence of exotic particles. Today, you can't do that. So one strategy is to build a simulator for the LHC detector and train a model on that. And then you take that model, and then you apply it to the real data. So in that case, there is no human involvement. It's a simulator. You know everything that's in there, Higgs boson, tau, lepton, this and that. And then you can carry it over, if you do a good enough job, to the real data. So those are two examples to answer your question.
Jim, NVIDIA's got ever more processing power at the edge, more in the cloud. I mean, are you seeing the need for human supervised training to go away?
Well, of course there's human supervised training. I mean, it's reinforcement learning. Some of the smartest PhDs in robotics spend more time just putting a ball in front of the robot, and so he kicks it and they put it back there again, and he learns and learns and learns. So, I mean, there's going to be humans who need to say this is the correct test data, right? I mean, you guys would know that for sure. I mean, but there's also going to be other activities going on. I talked about supervised, unsupervised. There's now adversarial networks where we actually pit the networks against each other. One's trying to fool the network, one's trying not to be fooled, and they continue to learn that way. But really, humans, our role is to set the goals, right? What do we want this to accomplish? How are we going to go through that process? But there's data in so many different places. I mean, I'll bring up SAP again. SAP has an incredible amount of data sitting in their systems. That is data that can be trained on, right? So it's not like it has to be just like the automobile industry where we spend a lot of our time. There's people from Daimler and others here. It's not just like the medical industry where Mass General has years and years and years of data that they're doing. But you're going to find it in so many different locations. I'll give you one example that's in the medical industry that I just think is astonishing, but the data was always there in front of us. If you're trying to determine the bone age of a child, right, to see if he's having growing deficiency, use really expensive MRI technology. You get a scan of the bone, and for years, guess what the authority that we went to? It was a textbook from the 1950s. You would flip it open, flip through the pages, and try to match that scan with the picture in there. Well, Mass Gen trained on that textbook. And now, instead of waiting days and hitting some inaccuracies, you can get the response in an hour, right? So the stress goes away. But think of that. So we always think like, oh my God, the data is going to be our biggest challenge. And it is. The more data you have, the better you do. And there's going to be an insatiable desire for data. But there's so many other examples where you can come about it. And I 100% agree that simulation is going to be the way we train a lot of things, right? You can't train all robots with real data if they're going to knock down buildings in the process of learning, right?
Right. Fair enough. Roz, you started.
Can I ask them a question? Can I ask
of course.
people a question, actually? I'm like fascinated by the driverless cars because when I get old, I'm going to need it. So, but do you know how sometimes you're driving in a car and you can just tell when someone's going to make a lane change into your lane? Have you guys solved that problem? Is that no? I'm serious. There has to be signs, right? We're processing some kind of signals that tell us.
So self-driving cars aren't just one network. Self-driving cars are many different networks. So as you mentioned, Mark, was there's the detection, right? You sense something, you take action. That's having an awareness of what's going on around your car and going from there. There's also the predictive. How fast is that guy going? Where is that a turn signal coming? How fast are they coming from behind me? You're going to have to do a predictive type nature as well, right? And then there's actually the training of the car and driving that is it's learning just by the way we like to do it, by watching. It watches humans, and it just constantly is going by seeing the cameras and learns the component. It's that and a couple other neural networks coming together, which is a self-driving car, an autonomous driving vehicle. And then there's different levels to that as well, right? Obviously, we're not all going to jump in a car tomorrow and say, let's go, right? Because there's going to be environments where there's going to be pedestrians who are still unpredictable, right? You're not going to be able to make those decisions. But there are different levels of co-pilot, right? I mean, you can actually have a car help you in driving. It will be able to predict that person's coming way too fast and the light is turning red, but they're going to plow for it anyway, and your car won't move because it's going to be protecting you.
Yeah, I never thought when I was working on autopilots that were actually autopilots, 20 years ago on airplanes, that it would help me think about my job today. It's a good question in part because I think there's different levels of different functioning models, and there's obviously a lot of companies working really hard on these types of problems. So I think it's fair to say that different companies are in different places. But real quick, a value chain of AIs in this example is that a pedestrian or a plastic bag? Is that a shadow or an 18-wheeler? Then it's more difficult situations. Like what's the intent? And what's most likely to happen? Like we'll do very well noticing a double parked truck that's never going to move versus one that's literally just about to cut you off. Right. But many of our customers don't have a shortage of data. Just to bring this down to the ground, they have maybe even too much data. And so the trick is getting the right labels and the right structure so that when they feed them into their models, they have some solid expectations of what they're going to get out the other side. And so I think, to just pick up on what Amir and Jim are saying, most of our customers are using every possible methodology to try to train and then validate their models. Mm-hmm. And there are some industries where, frankly, humans play a different kind of role at the back end because safety is involved or human lives are involved or healthcare is involved. And so it's not as big a deal if a social media company places a display ad based on some computer vision read of sentiment around it and gets it wrong. I mean, it's not good. Ask YouTube. But it's not as serious as, discharging a patient improperly from a hospital.
That's great. But let's move on related to what you've just been discussing around the value of data. So, Matt, in your case in autonomous driving, we're hearing that, and actually Jim as well, petabytes of data, terabytes of data being thrown off every hour with self-driving cars. I mean, how much data do you actually need to train an AI model? When are you confident enough in your AI model that that's a stop sign, that's a plastic bag, Matt?
It's a really good question, and unfortunately, the answer is it depends. And I'm curious to hear what other folks think. But in my experience working with a variety of different AI teams, sometimes it's more about having a smaller number of very precise, accurate data, and that can be on the order of tens of thousands of data points. It can be enough to train a model that's very accurate. And it depends on how narrowly defined the use case is one big variable. And it also depends how confident you are, again, in the precision. So if, for example, you're training a computer vision model, a classifier to recognize Dachshunds, as distinct from other dogs, you can probably train that with with positives and negatives, on the order of 10,000, especially if you're very confident. But we also have customers who need millions of images with millions of pixel perfect masks per image. So we're, 10 to the 6, 10 to the 6, 10 to the 12 data points that are several nines of accuracy on to train more sophisticated computer vision models. So at least in Mighty AI's case, we're definitely seeing a pretty broad variety. I guess one comment that I would add and throw out as chum in the water, there's all these articles, depending on how you think of them, as the frightening five or the fabulous five, the obvious big five software platform companies, Amazon, Microsoft, Apple, Google, and Facebook. These guys have just unfair amounts of data that's labeled in many cases. And the question is, do other companies really have any chance innovating in AI because of that? And to some extent, there is a law of diminishing returns past a certain amount of data, right? Do you really need petabytes? Sometimes, yes. And that can be a huge advantage. But can you innovate with megabytes? Absolutely.
Amir, Jim?
So I've asked this question from, I don't know the answer, so same as Matt, but I've had a sampling of people's views and the whole spectrum. So entities like Google, they collect enormous amounts of data, and potentially they're because of this, they own orders of managing more data than the next person potentially. So their view is actually that just more data and more compute leads to better models, leads to better products. So they're still going along this very strange trajectory of just more and more and more. And then there's my PhD advisor. I talked to him a couple of days ago, and he thinks that companies like Google are pushing AI into a really strange corner of the space where potentially you don't need to have 1 million images of dogs to be able to recognize a dog. Maybe the underpinnings of the field, the dominant form of machine learning or AI today is neural networks and deep learning. Potentially everyone's heard of this term. Potentially there's a problem with the models, and then we have to re-examine the models. There are other models that are similar to deep learning models, other connectionless models, sparse distributed, various names and so forth and so on. Potentially the models are to blame, and potentially in the future, a competitor to Google that has 1/100th or 1,000th amount of data can come up with a better model such that they don't need to have 1 million images of dogs to recognize dogs. Maybe they can learn it for the first time. And my personal belief is that this is what the future of AI holds. And it's like an optimistic view in that there's time for everybody still to get into the game. There's going to be lots of change. And that you potentially could have a small data set that's well labeled, or you can do unsupervised learning, and then you can go up and compete with the big guys. And I think these guys are really driving us to a strange corner of the space of AI, and we have to watch out because they're really smart.
Ross, the data set that you have, isn't throwing off the volume of a self-driving car. So how does it differ in your approach? In your world, in the media space, in managing and understanding that data?
Well, what's kind of interesting, and it struck me as I listened to them, is that, in the media space, you actually have a lot of, experimentation that you can actually do with your data set, right? Because if I get the recommendation wrong, well, nobody dies, really. So
it could be a boring night.
Yeah, it could be a boring night. And so there, we actually have, I think, kind of enough usage data around some of the things that we're doing, but a lot of our data is actually very North America and Western Europe centric. So by that nature, you kind of, you keep kind of corralling into the same focus area, right? So, we're always looking for ways in which we can expand beyond that. And I think in order to do that, we probably need to go get different data sets. But
actually, you're making an incredibly great point, so I probably can chime in. So I don't know if Google and Facebook are taking us into a dangerous corner, but they have a specific way of doing things. And they're probably going to win in general natural language processing and understanding in general. But in vertical, lawyers talk a certain way if you have ever interacted with a lawyer, right?
Yeah.
So there's going to be vertical aspects to this, even in the enterprise and different components, where there's going to be opportunity, and I do agree with new approaches to how they're going to go about AI. They may use different frameworks, different tools, et cetera. But I do think that's coming. So just like you're having a geographical experience, I think a vertical approach is going to be the exact same thing.
Yeah, and actually, we are applying our data to some very specific and focused media problems, which, I don't know, maybe Amazon would or maybe Google, but not. It's very specific, and so we're going to need smaller data sets to train those, but we're also looking at very focused. We're asking very focused questions. We're trying to solve very focused problems, and one of them is actually, and may have some overlap with the big guys, which is around advertising. But it's so very media centric, and I think what we understand is actually the specific problem that television advertisers will want to know, which is different from what these guys are trying to solve. But I mean, there's exceptions. You never know. But I think if you have very targeted focus areas, you don't need the extremely large data set. Like I think you said it. It's not, size doesn't always matter that much.
Quarter of the night.
So Ros, you made an interesting point about no one dies when you recommend the wrong film. But in the self-driving space, which clearly Intel's investing in, Mighty AI is increasingly focused on, it does matter. So how do you ensure in AI models that have been trained with massive data that you have that auditability, the traceability, that you actually even understand that how the AI model is working, to even understand is that stop sign or not? So Matt.
Well, most machine learning or all machine learning goes in a loop by definition. And, whatever your methodology, you need to have checks in that loop, quality checks. And, I think part of why AI has been slower to develop than it might have otherwise is it's difficult to insert those quality checks at the massive amount of scale and calculation that a machine learning loop is going to go through. So in the cases of our experience in the automotive space, what we try to do is put the right humans in the right loops, make sure we're asking the right people in the right ways, with the right domain knowledge or geographical, cultural context. What were those objects? What was that intent? And then integrate that, and so what's so hard and what we're trying to do for our customers is to basically provide human subjective judgment as an API, or as a programmatic interface that you can hit reliably, hundreds of thousands or even millions of times a day, and do that in near real time, not just to train the models, but again, to validate them in a continuous interface. So just like, if you go use your Amazon Echo or any other device and you say something to it, and it says, sorry, Jim, I didn't understand that, which is incredibly annoying, but you actually are providing training data right now to Amazon.
Right.
Unfortunately, in that case, not to the Amazon developer who built that app, but to Amazon. Right. And that's what we try to do at a massive scale. In the automotive case, I mean, it's incredibly exciting, as we all know, but it's also particularly, as you said, the stakes are high. And part of what I personally wrestle with, and independent of my role working with a lot of leading automotive companies, is what's the standard? And I don't know if I'm taking this off track, but it's there's all these famous stats out there. 94% of car accidents are caused by human error. We're distracted, we're drunk, we're whatever. We made a mistake. Average traffic coverage in an average freeway in the United States is 7%. During peak rush hour, it's 16%. So it's not hard to imagine a world where AI-assisted vehicles are smarter, way more efficient, less expensive, less polluting, and so on and so forth. And so I guess what I'm trying to imply is, what are you comparing the AI success to and safety? But yeah, you definitely need an audit trail, by the way.
Yeah. I mean, Amir, maybe, how do you know when an AI is right? Like, how are we going to be comparing it to, let's say, are we comparing a self-driving car to how a human would have acted, or are we comparing it to, a model of perfection?
Okay. So I'm not going to answer that question, but a related question, because I don't know the answer. When you're training, so in industry we see this all the time, that you have pretty difficult problems. For example, let's take the Chicago Mercantile Exchange, one of our customers. It's a large exchange. They trade a large number of securities and at a very fine time scale. There's orders coming in. There's a state machine that tracks bids and offers. This is a system that has to work very reliably with high assurance of success, because if it doesn't, it's a real problem. There could be a crash in the market, a flash crash. There could be bad actors doing really bad things. So there are AIs that you can use to enhance products for customers on this data. You have instruments flying around, and then you can tell if it's a good time to trade, if there's not people around, and so forth and so on. So when you train an AI in this setting, it's really challenging because one thing, it can't be a black box. If it's a black box, then the regulators will be unhappy. You have to have explainable models. They have to be transparent. And this is a real problem today because neural network models are notoriously non-transparent. And so I just want to answer this part of the question, that there are methods that people are developing to make neural network models, some of the most difficult models, to become transparent. And it's actually methods borrowed from neuroscience, my field, because these are neural networks. And in order to disentangle the complexity of these networks, you can actually do electrophysiology on the neurons in the model. You can look at one element of this model, and you can tell that this thing relates to some aspect of the limit order book where the market's crashing or someone's doing something bad. So there are methods coming online to make these things transparent, and also have assurances of things working in the future, as well as to have, if a bad event does happen, you can go back. The regulatory agencies require you to be able to look back. So a bad thing happened. Why did the AI make this bad decision? Why didn't you catch this? They require you to be able to go back and retrace your steps. This is good for me because it requires a lot more compute. And you. So a lot of these problems are intractable, and they can be solved with compute. But definitely very challenging. So detecting anomalies, I always get asked, can you find the anomalous thing in this data set? It's almost like it's by nature, this problem is unsolvable. Find the one thing in the million rows of data that's weird. We can't do this today. It's impossible. Even if you have a very good labeled data set, you don't have enough data to find that weird thing. But we're developing, the field is growing really rapidly to address these very thorny problems. That was very roundabout. That's as roundabout as it gets.
It's good.
I congratulate myself.
There's a loop.
So the answer was all of the above. I think one of the things you were really close to pointing out was it's important to have data, but also make sure your data is not biased, right? If you train, we all keep talking about self-driving cars, but if you're training something and you're only using the same data over and over and over, it's not going to learn enough, right? So that's why you do see, simulations coming. That's what I mentioned earlier about robots and being able to actually teach a robot in simulated world that is really a necessity for doing a lot of the things we're going to do. But if I only trained a car to drive around here, it's going to be really good at driving around here, right? And there'll be sometimes that makes sense for shuttles, for tractor trailers, pack car. Going to be having a lot of cars driving in the Nordics. It's really not that hard at night, when you're driving up in those areas. But you need to think through, if it's going to expand beyond that, what is the additional data you need? And can you simulate that data? Can you create that data? And how are you going to go through that process? That's a really key component.
Great. Okay, I think we've got time for one more topic before we go to Q&A. So Peter Levine from Andreessen Horowitz made this case recently about the end of cloud computing, and his premise was that more and more computing is going to happen at the edge. If I look at NVIDIA, I look at a self-driving car, massive GPU performance sitting at the edge. So, and then with the announcements this week about the iPhone having machine learning APIs available to developers, we're seeing more and more compute being available at the edge. How does that sort of impact how AI models are developed and instantiated?
Well, I just think AI models and AI approach is the answer to IoT. IoT has been this promise of connecting devices, and it's going to be all nirvana. We're going to get all this great insight. But a bunch of data hits all these devices that are connected, and we throw it all away because there's nothing smart enough to process it. So I do agree. I think the processing at the edge is going to be smart, trained applications. They're going to be at the edge making decisions. A lot of data doesn't need to be stored. It needs to be processed. You just need to actually understand and take action on it. You can't possibly store data on oil rigs, sensors, smart cities, all these kind of components. So to the point where this is going to take place, I think we're going to discover all the sensors are wrong. We put out these sensors for years and RFID tags and all this kind of stuff, and it's maybe not collecting the right data or data that we can actually process. You're going to see it. I mean, it's already coming in distribution. People ask me, when is AI and deep learning going to change retail? It's already changed retail, but it's doing it behind the scenes. It's coming to the checkout counter. It's coming out to your smart cards. It's coming to the end caps. So many things it's going to do, and that's really edge processing, right? Of course, there's going to be the equivalent. You're going to have to train the data back in a data center. It's going to go through that process, but the inferencing or the deployment of it is all going to be out the edge in so many different locations.
Amir?
We have a really good AI. It's the human brain, so I'll just go with an analogy. In terms of data center, so think of your cortex, or the prefrontal cortex as the data center, and think of your retina as the edge. So a lot of compute happens in your retina. It's not a camera, and it's not a CCD camera. It's doing lots of compute. Then your thalamus is doing lots of compute. Then your primary visual cortex is doing lots of compute. And I think the same analogy carries over to the world where mobile phones have a strict power budget. They will do a certain kind of compute, and they'll pass it on to a data center, which will do something fundamentally different. So all of these things will have to work in concert. They do it today, and they will in the future. The nature of the substrate and power budget and use on the edge is very different than in a data center. But all of these things have to be leveraged to solve really very difficult, intractable problems like autonomous driving. If you take driving for granted, it is very hard, and it requires everything to solve it. So just the common sense will prevail, I guess.
So Roz, your world's very different though, because there's maybe less need for edge compute performance.
Well, I mean, I think just to kind of go back to that, like I actually kind of think that we're just starting on AI and solving really complicated problems. And I think we're kind of at the beginning. So it would seem to me that, history tells us anything is we're going to exceed always the capabilities at the edge. Like you're going to probably, in the initial stages of solving these very complicated problems, going to be up in the cloud somewhere. Mm-hmm. And also, the newer your problem set, the more of the difference, the delta has to go back and gets processed. So I don't know that, aside from, and I'll talk about the TV and media, because I do actually want to answer that question. But I think you're always going to need more than what is available at the edge. That's my point, because we're going to keep thinking about different problems that we want to solve. In the TV and media space, I think that we're increasingly seeing. People are watching things on their phone, so there's a lot of edge power there. But what you won't see is, the heavy-duty set-top boxes, right? You're increasingly going to be on streamers, which are not, they have a lot of CPU and a lot of power, but it's not the same as putting, a full-fledged computer in the laptop. So we're going to increasingly, I think, see from a TV and media perspective a lot of things not happening at the edge. And so, but then, on the other hand, I think we were talking about this, turns out the cheapest storage is still the hard disk, which is at the edge. So if you're storing things, that's kind of a different. And, I know a lot of people say, and I'll just say this, that you can get, now in media and TV and media, you could get any content, anytime you want. It turns out that's not actually true. I think most of us have probably had this experience, or at least not for free, not for whatever you're paying your cable. So there is still this need to store things in the home, and that doesn't go away instantly.
Could I have just a couple quick points to draw this together?
Yes, please.
Real quick. So, one obvious need for edge is when you need extremely fast actions, and you can't always rely on connectivity to some complex cloud, and an easy example is the gaming industry. If you're in a first-person shooter or whatever it is, you can't wait around for the zeros and ones to pass through, from your gaming system to something in the cloud. Now, there's interesting arguments about that, and there's edge cases and so on, but at the end of the day, there's going to be, I really agree with that there has to be this mesh of compute power and all the models running locally and in data centers. And I actually think it's very related to what Amir was saying about the differences between sort of black box models and models where you basically have an etymology of the data. There's this amazing progress with Google Translate recently, which has been very well covered in the media, and it's amazing. And if you read or talk with the folks at Google who helped create that amazing ability to translate in essentially real time between, a growing corpus of languages, they'll tell you that there's this black box in between that creates a different language because it translates, from Portuguese to some other language in this black box into German or whatever. They have no idea what's in that black box, and that's not fair. They don't know what that language is, and they can't speak it, and the computer can't speak it, and no one can learn it. And it's brute force. It's amazing, and it's providing a lot of services, and lots of people use it, and it's a beautiful thing. But I'll use the car company example just to bring this home. If you have an automotive system fail, for example, European regulators want you to spend 10,000 hours testing every new software update to your automated braking system, and they want to know when it fails, why it failed. And believe me, you do too. So a black box just doesn't work. It doesn't mean you won't use a variety of networks and models and methodologies, but at some point, especially in regulated industries, you need to be able to trace the data.
Great. Well, let's move on to questions.
Do we know how the brain does it? I guess if we had a little kid standing here, I wouldn't need to show him 10,000 schnauzers, right? I'd need to show him 5 schnauzers, and he could figure out what a schnauzer is. How does it work in the brain versus how it works in AI?
Let's ask someone who studied that.
If only we knew someone.
Perfect person.
So this is an unfortunate thing, but the more I study the brain, the more I realize I didn't know how it worked. It's a really fun, interesting problem, but I don't really know how to answer this other than the data that you suggested that children seem to learn differently than our models do. That Google Translate is very different than how a child learns language, And this is a problem. And this is a problem that's happened in the history of AI several times. And it's a very dire problem because it's caused these AI winters. I don't know if you've heard of them. And it starts with Skinner and Chomsky in the 50s and whoever. It's Google versus me or someone else today. The remarkable performance in a machine learning model in industry is one thing. Like, these are material things that can help people make money or users be happy. But whether or not we understand AI as a result, how a human does it, maybe it's immaterial. But to me, it's not, because I'm a neuroscientist. But it's a great question. And again, I would say that we should be optimistic that we're going to figure these things out, and it's going to make things a lot better in the future.
Yeah. I'd like to add a little bit, though. I mean, because we keep talking about this is a black box and humans are so much easier to understand. I think you've maybe seen some recent events when we think we understood what we saw and we try to get the trace. It's not that clear. I mean, we're all kind of black boxes. When we talk about human error, it's an important thing to discuss. Because if you challenge the human on their error, they're not going to be logical and upfront about it and go through this process. It's just not. So we have to understand that we're almost setting a standard where we think humans are auditable and machines are not. I do agree we're kind of early. If you guys remember, it's only been almost 5 years since Alex Khosrowshahi brought about AlexNet and destroyed the ImageNet contest, and deep learning saw its resurgence. I mean, so it is early on, but if you look at everything that's happened in the last 5 years from now, to say we're going down the wrong path is to say we're making incredible progress, but I have another idea. And I think that is true. That has been what's been going on in the machine learning AI space. You know, Jan LeCun did not just join this revolution when Alex Khosrowshahi. He's been in this space forever, and he's solving incredible problems, right? So Andrew Ning is solving incredible problems. And I think we have to also realize there may be different approaches that come in the future, and we'll adapt to those. But right now, we're seeing incredible benefits that our accuracy rates are so much higher, right? A machine can now read your lips at 93% accuracy rate. Most of you won't really cross 53 if you work really hard at it, right? A machine can look at MRI scans and be in the 90%. Most trained people who've been working in it for the rest of their, for all their lives, still make errors. So we gotta also have a balance here where we're not going to just say, we all think this is the end of humans because AI is going to be really strong. No, it's not. It's actually a partnership. It's going to be us guiding the process. And you have to have that level of confidence. And I think we're just going through a cultural change. I think we can all think back of the first time you walked up to an ATM machine and said, nope, not going to use it. I'm going to see my teller, right? Or the first time you were asked for your phone number when you were at a grocery store, you said, nope, I'm not getting my phone number. I don't really want them to understand that, I drink beer and eat cheese and buy, unhealthy bread, because we think it's going to be used against us in ways that aren't. But then we get comfortable with it. So my component is, instead of just saying black box, let's let the history point out. Let's see the accuracy rates that happen. Let's see what happens when we can get to that. And then the confidence will build. Nowhere in healthcare will HIPAA ever let this replace a doctor in any time soon. But it is great to have a second opinion right there in real time that is finding something that somebody missed. And I think if we start thinking like that, we'll open up our eyes to what AI can do for us.
Next question.
So now that computer models have beaten the best chess players, we have freestyle chess. It goes by some other names as well, where you have teams of humans and computers playing against each other, and this purports to get better results than the computer by itself. First of all, is that true? And second, if it is that a way that we should be a model we should be thinking about for how AI will evolve?
I'll start.
Chess actually lost in 1997, by the way. So the computer's been good. The more recent has been the game of Go that Google drove, and that is a much harder, intuitive game of patterns. And I would encourage, we won't need to talk a lot about it, but I encourage everyone to go look on YouTube, and I think they got this one right, so it's okay. On YouTube and Google Move 37, where the computer AlphaGo actually chose a square that most humans would not have chosen, and the commentators even said it was an error, like they questioned the accuracy of the move. So I think humans will always come up ways to change it, right? So we can talk a lot about what AI is doing in art, My daughter works in art. She always reminds me that humans will come up with new ways to leverage this stuff and do it. So yes, I do think there will be ways that humans can gang together and come up with different approaches. And I think it's exciting. That's what keeps us going.
Yeah, briefly, just to build on, Jim, your answer. I think, those games have defined rule sets. And, that has made it easier for machine learning scientists and engineers to play out, billions and billions of permutations and teach models the rules. And part of why computers have been winning in those types of rule-based games is because they can play through millions and billions of possible permutations much faster than any of us can. And we learn over patterns and synthetic observations and so on. But I guess another way to think about it over the long term is I think an AI is only as useful as its application, which sounds really obvious. But the short answer to your question is no. I don't think that's the right model to think about the future of AI, because I think the right model, as Jim is saying, is something that's more about how will computers make us better at whatever it is we're doing. And a lot of those parts of our lives, whether it's how we find our mate or we shop or we learn something new, those, how we convey emotions, those are all very subjective. It's what makes us special, right? What makes each of us unique. And eventually, long term, I think AIs will get not only more intelligent, but much more paired with us in the way that we can enjoy ourselves in subjective context. And so it's the wrong model to think about it, because I don't think long term it will either be adversarial or simply in objective context. I think it'll be collaborative and in much more subjective contexts, like art or education or healthcare and so on. But as Roz said, we're in early days. That's my
Let me add something
opinion.
It's
to
going to
what...
make for a great movie, though, Roz.
Yeah. Well, actually, I have something to say about that. But, let me just add something to what you said, Jim, about doctors. So my daughter is going through med school right now, and she spent basically her first 2 years memorizing a bunch of stuff. And so, she's going to spend the next 2 years actually trying to use that knowledge. So it would have actually been much better if she didn't have to rely on her memory or always to look things up. So if it was I don't believe the machine will ever replace what some of the emotions and the personalization that the doctor can actually bring for each of the patients. So that's not going to go away, but it is basically a cooperation. A lot of the memorization and just learning about new things doesn't have to be, part of what the doctor has to do from day to day. And you always, if you think about it, if you have the AI, you will always be able to benefit from what other doctors have learned, which is not something that's really even doable, today. Mm-hmm. So I think it just, it changes what humans can do. And, hopefully it's better.
So to play devil's advocate on the original question, so AlphaGo was a remarkable achievement by Google. People have thought 25 years from now we'll figure this out. But if you look at AlphaGo more carefully, there's Go experts who design the games. There's a corpus of many, many, many human games played by experts that this machine has access to. So it's the human intelligence that potentially seeded the training for this model. And then just going on a tangent, AlphaGo is a very highly prescribed, defined scenario, as Matt pointed out. And potentially these are easy problems to solve in the AI space. Maybe the hard problems of AI are still hard. And if you go on YouTube and look at robot competitions where robots are trying to do very trivial tasks, these are the top teams from various universities. Robot, get out of the car and open a door. You will see a lot of hilarity ensues. The hard problems in AI are sometimes not intuitive, and I would say that chess and AlphaGo are actually not the hard problems of AI. Highly controversial thing to say, but I would just urge you guys to think about what is actually hard. Is it to play chess, or is it to get out of a car and open a door? And I would say it's the latter that's much harder.
Next question.
First off, thank you, all 5 of you, and the Churchill Club for what's been a very thought-provoking evening. Sid from McKinsey, and just 2 questions, one on fear and one on hope. First on fear, how far away are we from Judgment Day, as described in the historical documentary Terminator 2 Judgment Day? And second, on hope, as many of us in the room that don't necessarily have a technical background and aren't AI experts, what do we really do to stay relevant as people in the workforce in a world that is increasingly AI-driven? Thank you.
What is the actual Judgment Day from Terminator movies? So
the machines achieve sentience and kill us all.
So the chip line that we were making at Nirvana, my startup, they were named after T100, T1000. That's my only comment about this question.
I think it was part of our earlier thing. I don't think there's the Judgment Day kind of capability. It's not a big, you can call it what you want. I don't think there's a point where we have to be fearful and go from there. There's on the hope side, think about what it's going to do for food production when you don't have to overwater, over-insecticide. There's going to be so many more benefits that I know we love to, again, it's going to make a great movie. We're having another Planet of the Apes coming out, so why not another one of AI taking over, right?
Sure.
And by the way, humans will make great movies.
Yes.
I mean, we have actually done a lot of kind of analysis of movies in terms of like the scenes, the location. There's probably about 10 different, like the mood and all of that. And so we have like great data around describing a particular show or a movie. And, the cast, there's a lot of predictions around, okay, you have this director and that cast, and you're located here. Is that going to be a movie? And we never would have predicted Get Out. Okay, so, I mean, that's, there's a lot of things in there that right now, at least, I don't see, the machine solving. Like, we're still going to do all of these things that calls for human creativity. I believe.
Just to add, I think it's the first question is an important one to ask. Just like asking these big questions like, who are we and why are we here? And when very serious technologists like Bill Gates and Elon Musk are concerned about the long-term future of general artificial intelligence, when machines actually achieve something resembling sentience and the ability to not just be trained, but to teach themselves and extend that knowledge. That said, I really, again, been laboring in the trenches with literally dozens of the world's best AI companies for the last few years. That is so far out, it's imperceptible to me. There are so many more profound global problems that humanity faces that are actually real here and actionable. That said, the reason I personally think it's an important question to ask is because there are many, I would say, very present dangers that are more humble versions of that big question. And to me, they can be summarized as bias. Jim mentioned this. If you train a machine, with biased human judgments, then there's a real problem there, and it may indeed be difficult to detect depending on your methodology and the application of it. And there's famous examples, but the one I'll mention is some parole officers in the United States were using machine learning models to predict recidivism. Should we let this person out of jail, or are they likely to commit a crime again? And they used it in the real world, only to find some amount of time later that they had been not only poorly predicting recidivism, but they had been denying parole to black people more often than of other races. And the reason was how the models were trained. And there's lots of other examples. So I'm a lot less worried about the Singularity or Terminator Day, and I'm much more concerned with, are people applying their machine learning models with a representative set of data that, often take unethical implications. So that's a real quick answer to the other really imponderable question is, to use Jim's example, ATMs created more jobs than they destroyed. There was a lot of disruption along the way. And if you want to, I think if there's so much data, as Robin mentioned, if you want to stay relevant, learn something relevant to data, which could be anything.
I'd like to add that I don't think the Singularity is coming. either, but I'm glad it was Amir and not me who stood on stage and made fun of robots and laughed at them. Because when they see those videos in 50 years, they're coming for him.
I'm pretty sure it's okay. If the robots do take over, the robots will decide, hey, wouldn't it be cool to have humans? And then they'll create us, and then I'll be back, and they'll be a cycle. My prediction, you can quote me.
On that note, next question.
I have a much more tactical question. You were talking about the top 5 AI companies. I noticed that you did not include IBM Watson, and I'm just curious, does Watson fall short? And if so, why? And I don't work for IBM. I'm just curious.
There's lots of IBM people in the audience.
I know.
Yeah.
I know. I'll never make it out. Actually, to correct the record, I did not say the top 5 AI companies. I was actually sort of paraphrasing the New York Times, which has coined this phrase, the frightful 5. And I sort of jokingly called them the fabulous 5 because I think it all depends on your perspective. But full disclosure, Mighty AI is a partner of IBM Watson. We've trained Watson, for example, to have conversations about golf. We've helped big companies use IBM Watson. So, I think it's early innings, and lots of different companies have different strengths in AI. And there's no question that IBM has tons of smart people investing billions, literally, in AI. So, I think it all depends. I could offer you a range of unqualified opinions on who's good at what, but I think it depends.
Yeah, let's not.
Yeah, I won't do that.
Next question.
There's a lot of great. I mean, I don't think we mentioned Baidu, Tencent, and a bunch of other companies in that space too. So,
totally.
Next question.
So I just wanted to ask a sort of odd question. So it's fantastic that AI can do data analytics and deal with diseases like sepsis and find out when someone goes into an ER what looking at 1,000 tests and be able to say this person's organ's going to fail and so on, and really help in those kinds of ways. And there's all sorts of things with seeing faces, and maybe Stone Cold Killer face will be identified and we won't have as bad terrorism. But how do people who aren't doing these super lofty things engage in AI? Because it seems to me the space right now doesn't have a play space for people who aren't at Stanford, who aren't in CS. I mean, there are people around it who are in ethics, and there are people around it doing all sorts of things, and people can do things in other countries in small ways. But I'm just saying, it doesn't access to AI platforms that are any good. It's really, really hard for people to play around, especially people who aren't technical. Have you guys thought about identifying a way for people to play who aren't part of your culture in a really focused, direct way?
I think, well, first off, our culture. I think it's our culture, by the way. So take it up from there. I believe that it is becoming much more accessible. There's not a cloud provider in the world that you can't actually spin up, an instance that has the frameworks that you want to play with, and it's not just one framework. It could be, could be TensorFlow, it could be CNTK, Cognitive Toolkit, it could be any of them, MXNet. There's so many different ways to get started. There's plenty of courses out there now how you get started. I will go ahead and mention again how SAP is using it is not what we're talking about solving cancer. Processing invoices is an incredible AI procedure, right? So that you don't have to wait 6 weeks to close your quarter because you have to go through all those kind of components. I think it's coming in already to everything we're doing in so many different ways. Most of us, when you park, Google knows where you parked. It's going to tell you where to go to get your car afterwards if you set that up. So it's becoming more and more accessible. If we go back 10 years ago, AI was not that accessible at all. I mean, it was, so the compute capabilities out there, it is showing up everywhere. It's moving to the edge. It's moving to the cloud. So I would say just keep chasing. It's going to be there very fast. There's at least 7 keynotes that I've saw in the last 6 months of companies that are democratizing AI. So therefore, it must be coming.
There's a couple of quick pieces of advice. All of the companies that we just mentioned, including in Asia, have websites where you can, for example, drag a photograph or a snippet of speech or text and see whether a computer can recognize it. And some of them make it actually pretty accessible to train what's called a classifier to recognize the dots on its own. I don't know. The other thing I would briefly add is it's a great point Jim made. I mean, machine learning and AI are, to me, more like math than they are anything else. And so if you really want to tinker with machine learning, take a free course from Coursera or something else on machine learning, or just, learn vector calculus, which that's big. But it sounds funny, but there's this famous quote, software is eating the world. I mean, machine learning is eating software. So, it's everywhere.
Yeah, my advice would be, if you want to tinker with it, figure out a problem you want to solve, and then go figure out, where you get your tools. And, Microsoft, everybody has tools that you can play with.
Great.
But start with a problem.
Next question.
Hi. So you mentioned a couple of scenarios. You mentioned HIPAA. You talked a little bit about the mercantile exchange. And I know that AI is really early on, but I'm curious about the ethics as you move forward, and where do you draw the line and who draws the lines? And one scenario that comes to my mind, for instance, is, could an investment firm use AI to predict the stock market or investments, and is that ethical or not ethical? Where are the lines in your opinion?
Amir?
Oh, boy. Okay. So on the ethics side, we had a couple of questions on that line. Are machines going to take over is the most extreme case, which I think is a distraction. I think what Matt mentioned, bias in data sets, just more perfunctory things, are actually the pressing issues that are not being attended to. And that's along the lines of your question. So the truth is that we call things AI today. These things have been around for a long time. So this generation of neural network models that have made these great improvements are, because I've been in this business for a long time, they're just an incremental step in the history of this area. And financial institutions have been using these methods in a different form for a long time. So we have a history of machine learning being used, and it's not been a disaster. There's other things that have been disasters. There are structural issues with the financial markets. You have mortgage fraud and other things. But in terms of policing institutions using machine learning models for nefarious purposes, I think that's a valid concern, and that's a role that regulatory agencies play. And I would say that currently it's actually really onerous. That I mentioned that you have to have a trace of what you did. Like if you're a bank that has currency trading across a million points of sale, it's really onerous for them to track everything to make sure that some person in some foreign office is not doing something nefarious. But actually, I would like to hear the opinions of the panel on this.
I would say in the financial world, if you look at the different quants who basically are data scientists who actually trade during the day and then actually have to do their own hand-coded machine learning, they've all had their own individual components. So I think that's been hard to trace to some degree too. But yes, I guess you could go back and ask them to justify it, and they could try to dig it out. I just look at it from, it becomes an accuracy. You can ask how many of these quants that have been having to stay after work and doing these machine learning, but from hand-coded standpoint. So there is this idea of an expert system that you could train that helps you with it. And they're delighted to actually see this transference to where actually there's a network that is helping them processing and doing the evaluation, et cetera. And I do agree. I think what we do need is more tools to help them make that more transparent, not go backwards. So, and I think, again, we've been saying this all the time, that's what our role in this is, to be the ethical people. As we make things more efficient, how do we ethically make sure that actually flows through society correctly? And that's what, we're supposed to do as the humans here.
Great. Time for 2 more questions. Next question.
I think he's been...
So on the hope side, to your question, we actually use ML to train youth and young women who have 12 standard education to train AI for your self-driving cars. So it is absolutely possible, I think, AI can actually be a bit of an equalizer. But the question I have for you is, where do you think AI, as we move forward and it becomes more mainstream, has the largest, the highest, broad societal impact? Will it be in agriculture? Will it be in water? Where is the broadest social impact that AI can bring?
Boy, that is like such a great question. Very hard to answer because I do think.
What about top five?
Yeah, top five. I mean, I think you named some good candidates. Machine learning, or boy, Amir's made some really important points that it's actually been around for decades, and yet it does seem with the incredible compute power that NVIDIA and Intel and other companies are bringing to bear, new and tremendous amounts of data, that the field is accelerating in its progress. And so I'm quite confident that in our lifetimes, God willing, we'll see tremendous advances in agriculture and in transportation. I'll mention one last factoid about transportation for the day. Here in the U.S., fatalities from car accidents are actually up 30% in the last 3 years.
Number 4 killer in the United States.
And, reasonable people can hypothesize as to why that is. I have a personal hypothesis that it's not that people are drinking more or whatever, it's that we're doing this. And so we're in this horrible interregnum where technology is actually making it less safe to drive, despite tremendous advances and efforts by lots of people with things like emergency braking and lane maintenance and so on and so forth. So I think transportation is a big one. Because I think healthcare is a big one, but I'll throw you a curveball. My bet is that the biggest impact is going to be in education. Because education today, for those of us who went through schools in the 20th century, it was like, here's your subjects, and you go through this curriculum, and it's very fixed, and you will take chemistry, and you will take biology, and English literature, and whatever. But that's a very rote sort of definition of human knowledge, and I personally think over the next couple of decades, there's going to be a much more granular set of knowledge and ways to learn it in interactive modes. We haven't even touched on augmented reality and so on, but I think it's going to be, our kids and our grandkids are going to learn in much richer, personalized ways, and who knows what that's going to unlock. That's a guess.
I like that.
Amir?
Yeah. Well, my hope is that we make a lot of strides in healthcare, because I think it's, still a lot of guesswork. I think, medical science is not that exact, and I think AI can really help with that. And I'm also hoping that if that is true, that we'll attract a lot more women to get into the AI field, because. Right. It has more sort of a society impact appeal to it.
Amir?
I don't have much to add. I guess maybe to be more of a counterpoint. So the AI field is moving at a very rapid pace. There's lots of innovation. But I guess one question is, in 3 years, is Siri going to be able to converse with you like a human, or is it just going to be a little bit better? And I'm thinking that potentially the scenario is that it's going to be a little bit better. That autonomous driving, is a car going to be driving you around like in the Jetsons or whatever? It's very unlikely. I think it's going to be more like the Tesla of today, just better. So I think the near future is you're not going to be overwhelmed all of a sudden by robots wandering around and doing crazy things. It's going to happen very slowly, and there's technological and algorithmic improvements that are necessary to solve hard problems. So I don't want to depress anyone, but this is a lot of work. We're in the trenches, and the people who are doing the engineering hear the CEO of the company say, we're going to have flying cars. It's like, what? I can barely get this thing to go straight. So.
Brilliant. Okay, final question.
Hi. I don't know. I think it's working on. My question is to Matt and Amir. I think to the earlier point you made around the nature of neural networks, do you think the AI winters were a result because there was this insane amount of focus on following neuroscience-based methods versus probabilistic methods, where a lot of math is involved. Like you see companies, like I know a couple of companies in Boston that are doing stuff that is exclusively, using Bayesian methods and probabilistic methods, and they've been around for a while. So that's one. And the second bit of the question was, so David Deutsch who is a theoretical physicist at Oxford, he's written a wonderful essay where he goes on about artificial general intelligence and some of the key aspects around that. And he says, and this is from what I understand as well from today's discussion and today's conversation, is that AI is not essentially a computer science problem, but more of a math problem. And what I mean by that is that the understanding and the reasoning faculties, and some might even say it's an epistemological problem. So,
Amir?
So on the AI winter side, I think the reason why AI winters have happened is because of hype. That there's been consistent over-promising and under-delivering. And we're doing it again today. And I am part of the problem, as well as potentially other people on this panel. It's late in the evening.
It's not just the robots going after you.
Right. So I think that's the reason. And you see it everywhere. You see just ridiculous statements that, I have to watch myself because I still answer to my PhD advisor. If I'm here today and I say to you that, yes, we're going to have generalized AI in a couple of years, he's going to, what are you doing? It's not going to happen. It's irresponsible. And the custodians, the people who kind of were responsible for this latest AI resurgence are really wary of overpromise by business people. There's lots of people who go and download a framework or something off the internet, and all of a sudden they're AI experts. There's a long history to this field, and there's been ups and downs, and the hard problems are still hard. So the AI winters, I would say, is caused by hype. On the physics side, so I really don't know how to answer this question, but physicists are wonderful sources of just crazy hyperbolic statements. So, and it's really great. There's Max Tegmark at MIT. He's really wonderful. There's people who've conjectured that the world is a computer, a simulation. I don't know how to answer the second part.
Well, gee, I guess I better provide a counterpoint,
Yeah, I guess I'm like the downer of the panel.
Yeah, just for fun, if that really was the last question, let me give you another vantage point. I mean, look, I do think that machine learning and/or AI, depending on what you call it, is all around us, and it's becoming more so. And I agree, Amir, with your point that a lot of the progress will continue to be incremental. But to me, it's kind of like hiking up a mountain. You're chatting with your friends, maybe you stop every once in a while for some gorp, and then all of a sudden you hit this beautiful vista, and you can't believe that you made it there. And I think that's what's happening in AI. And, I respect, you know how much I respect you, but I do respectfully disagree, and I do think, to Jim's point a little bit ago, we will see fully autonomous vehicles in the next few years in limited domains, in urban environments with set routes. And I think that's going to transform transportation as much or more than light rail did. Mm-hmm. And there's going to be other examples in healthcare, in imagery. As to your point about, I do think you're implicit in your question, though, is a reminder that it's really fun, and part of, I think, why each of us here are happily laboring in the trenches in AI is that it is early days, and presumably that's at least part of why you came tonight, is you're curious about it. And you mentioned CNNs versus probabilistic models. Without going down a huge rat hole, my company uses both, in different scenarios, because they're different. And it's entirely possible that in the next few years, new methods will come to bear fruit. But I really do... I have a slightly more optimistic view. I don't like hyperbolic promises, but I definitely think it's just changing a lot.
Yeah, and I think you guys missed on, you're trying to solve really hard problems, just the really hardest problems. How do our brains work, right? What you're sort of missing is that as you're going along the journey, there's a lot of work that has resulted in some really profound changes in different industries. Maybe not all as impactful as driverless cars. But there's a lot of, it's why we went to space, right? It's all the technology we got from trying to go to space. And so a lot of that is happening. If you don't just all focus on, okay, we got to build these, super intelligent robots that are smarter than us. So all the work that everybody's doing is, yielding a lot of benefits already.
Thank you. It's Karen.
Well, don't get out your
That's sharing your perspective so candidly. We appreciate it. Thank you. We do have a small token of appreciation for you in the form of a Churchill Club speaker T-shirt. Robin,
Thank you.
I'm surprised you're not wearing one tonight.
That's all I wear.
A recording of this program will be available on our YouTube channel within hopefully 24, but definitely 48 hours. And you'll find other recordings of our programs there as well. We hope that you find that to be a useful resource. You have been a wonderful audience. Thank you so much. Have a great night and see you next time.